Authored by a veteran chemistry teacher, Abdul Shakur, these two textbooks provide all the essentials that would not only enable students to master grade 11 chemistry, but to excel at the next higher level in this subject. What make these texts unique are their creativity and profundity with which concepts are explained for clarity and mastery. The following is one of a set of 44 different tutorials created by the author, using materials primarily from the text Chemistry 11 in Focus. I hope you enjoyed this video. If you liked it, please give it a thumbs up and don't forget to subscribe. We will see you in the next video and thank you for watching.
Our lesson today deals with finding the molar mass for compounds. And we'll be looking at how we find the molar mass for molecular and ionic compound and the molar mass for hydrated ionic compounds. And the lesson begins on page 155 and it ends on page 160 from the text Chemistry 11 in Focus. First of all, we want to distinguish between molecules and formula units when we are speaking about different types of compounds. Water is used to exemplify this, water and carbon dioxide. Here you're seeing how a molecule of water is formed. We've done that already. Two atoms of hydrogen here are combining with one atom of oxygen to give a single molecule of water here. That's the ball and stick model there. If you have water, it will be existing as molecules. Okay? Carbon dioxide is another example of a molecular compound. So here you see now how two atoms of oxygen are reacting with one atom of carbon to give you a molecule of carbon dioxide here. Okay, ballistic model there. Now, when you talk about a formula unit, we are referring to ionic compounds. Here you're seeing how one atom of sodium is reacting with another atom of chlorine here to give you sodium chloride. And this will be referred to as a formula unit. We cannot say a molecule of sodium chloride. That's why I'm taking this opportunity here to distinguish between molecular compounds and ionic compounds here. Like how you refer to these here as molecules of carbon dioxide. In an ionic compound, these repeating units of Na and Cl are called formula units. Okay? So know the difference between the molecules and formula units. When you have a formula unit, it doesn't necessarily mean it has to be one atom of the metal or one atom of non-metal. You can have one atom of a metal here and two atoms of the non-metal, as in calcium bromide. What type of particles, molecules, the formula will present in these? Oh, this is an ionic compound, so you know what you expect. Molecular compound, ionic compound, molecular compound. Okay? This will be formula units. This is going to be molecules. There will be formula units. Let us say you're asked to calculate the molar mass for carbon dioxide. Let us see how a molecule of carbon dioxide is formed. In forming a molecule of carbon dioxide, we're using one atom of carbon and two atoms of oxygen. At the atomic level, this will be 12.01 atomic mass unit, 16.0, 16.0. So the molecular mass of this, it will be formed by adding all of these here together, and it's 44.01 U. Small. Now if you want to know its molar mass, we can do it two ways. Look, we have carbon. You're using one atom. Of course, if you use a mole of this, then you have to use another mole of this. You have a mole of this and a mole of this, okay? If you want to find the molar mass of this guy here, it means that this is coming from 1 mole of carbon and 2 moles of oxygen. So we do it separately so you get a big picture. So the molar mass of this will be found by multiplying this by Avogadro's number, and we did that in a previous lesson, and that will be called 12.01 grams per mole. 1 mole of oxygen atom will weigh 16 U times that Avogadro's number, and you end up with 16.0 grams per mole of atoms. Same thing here. So when you add all of these up, this for carbon, this is 1 mole of oxygen, and another mole of oxygen, you'll end up with 44.01 grams per mole of molecules now. Or you can do it like this. This is the molecular mass, and you have a mole of that. So you take the mass for the molecule here, which is this. So this is the molecular mass for carbon dioxide. You can take that and multiply it by Avogadro's number, and you get its molar mass here, which is the same as adding this, and adding this. So I just want to show you in a big picture how 1 mole of carbon dioxide really came from 1 mole of carbon atoms and 2 moles of oxygen atoms. So if someone were to ask you to find the number of moles of carbon and oxygen atoms in this, when you decompose that, you should be able to say, look, I'm going to have 2 moles of oxygen here and 1 mole of carbon there. You don't have to do it like that. You can do it in this condensed method here. Okay, inspect this molecule here. And then see how many atoms there are, and you express that in grams. So if you have carbon dioxide here, you have 1 mole of carbon, and this 2 moles of oxygen atom. You go now and you do it like this. You take 2 moles of oxygen times its molar mass, and you get that is the mass of the oxygen component. You have 1 mole of carbon times its molar mass, and you get that. And when you add them all up together, you end up with this as the molar mass for carbon dioxide, and we showed you that before. Now let's do some other compounds now. How do you find the molar mass for compounds with radicals? We have alluded to this already in a previous video. We talked about radicals, okay? The molar mass for the compound you're trying to find is calcium nitrate. Here you see it has 2 nitrate radicals, right? So if we break that up into the radicals, you'll get 1 mole of this guy here, okay? Will produce 1 mole of calcium ions. But look, we're treating these radicals as groups. Remember we said that the nitrate ion is really like this, where 3 oxygen atoms are bonded together. So when they move as a block. So in here now you're going to have 1 mole of nitrate ion there, and another mole of nitrate ion there. So you get 2 moles of nitrate ions. So when you break up this one here, you get 1 mole of calcium ions, 2 moles of nitrate ions. Now if someone were to chop these up now, decompose this radical there, chop it up, what would you end up with for each? Like if you do that there, what will you end up with? You'll end up with nitrogen here, and you'll end up with 3 oxygen. This one, and that one. Okay? So that's what we're doing here now, to see how many individual atoms are there. So this guy can be broken up into nitrogen and 3 oxygen here. This one here, this other nitrogen here, and 3 oxygens here. So in the end, how many moles of each element will be there? Look, this guy is only 1. You have 1 nitrogen here, and you have another nitrogen here, okay? So then up 2 moles of nitrogen, 1 mole of calcium, and look, you have 3 and 3, 6 moles of oxygen. So when you want to find the molar mass of a compound that has radicals, look at the compound carefully, identify those that are not radicals, and you separate them. You have 1 calcium here, and then you separate the 2 radicals there, okay? And then you count the number of atoms inside each. We're doing this separately, but when you do it, when you get accustomed to it, you'll just say, oh, what? I have 1 calcium here, right? And everything inside the parentheses, because there is a subscript of 2 here, you multiply everything inside there by 2, because it means you have 1 like that, and you have another one like that, right? And this one here brings in 3 oxygen, one nitrogen, and another nitrogen, right? So you take this 2 and you multiply the nitrogen by 2, and then you multiply the oxygen there, you have 3 of them by 2, and you end up with this value that I have here, right? This is just for you to see. I'm doing this illustration for to see really how you ended up with these values here, okay? All right. Let's see how you go about doing the molar mass with that now in a shortened way. So you have 1 mole of this guy, 2 moles of these, and 6 moles of these. All you do is to multiply them by their respective molar masses, and you add them up. So look, you have 1 mole of calcium, you take this molar mass, multiply by 1 mole, okay? You take 2 moles of nitrogen, multiply by molar mass, 6 moles of oxygen, multiply by molar mass, and you end up with this as the molar mass for calcium nitrate. You can have another one too that has radicals, okay? What are the radicals? So in this case now you're having 2 radicals of ammonium ions. So same thing we do here, all right? See? Because you have a 2 here, it means you have 1 radical there, another radical here, but sulfate is only 1, all right? Here again we can break all of these up. Look, if I break these up, I'll have from that 1 nitrogen, all right? I cut that bond there, I cut that bond there, I cut this bond here, and I cut that bond here. From this radical, I'm going to have what? 1 nitrogen and 4 hydrogen. So from 1 mole of this, from 1 mole of radical here, which is this, and I break that up, I end up with 1 mole of nitrogen. Same thing for this other one here, another mole of nitrogen and 4 moles of hydrogen there. If I have a mole of this one now and I chop it up there, okay, chop it up, what do you have? I'd have 1 mole of sulfur here, all right, and these 4 moles of oxygen. So sulfur and 4 moles of oxygen here. So totally what we have. If you say that we have 2 moles of nitrogen, you're fine. You say we have 8 moles of hydrogen, these 4 here and these 4 here, you're right. 1 mole of sulfur and 4 moles of oxygen. So what you do now is that you do it in the condensed way again. Find a mass of 2 moles of nitrogen, all right, 4 moles of hydrogen, 1 mole of sulfur, and 4 moles of oxygen. Okay, same thing we're saying here. You can read that if you want to see some more explanation what is happening there. All right. Same thing we said. 2 moles of nitrogen, 8 moles of hydrogen, 1 mole of sulfur, and 4 moles of oxygen. Okay. Just explaining to you what I did there just now. You can read that, digest it a little bit more for your own benefit. I know about it. So you read that, get some more explanation there. So that's what we do here. You find the molar mass of 2 moles of nitrogen, and that's it. 8 moles of hydrogen, that's it. 1 mole of sulfur, 4 moles of oxygen, and in the end you end up with this answer, okay? That's how you find molar mass for things that have radicals. Without radicals, it's easy. Molar mass for diatomic molecules. Remember we said in some cases you have hydrogen. Hydrogen is different from H2, right? If you want to know the molar mass of this guy, it will be equal to 1.01. But because a molecule is twice that, you'll have to double it up, right? So all of these are diatomic molecules, and the molar mass for each of these will be twice that what is this for the atomic mass. Sometimes this is just a reminder when you write chemical equations, how not to write this as atoms, okay? When these elements there are produced in chemical reaction, when they're used in their uncombined form or elemental form, they're always in the form of molecules, okay, and not their atoms. You only find their atoms when they come in a combined state. So this must not be shown like this. It must be shown like this, okay, as molecules. It's just a quick reminder when you write chemical equations. So why is happening here? Why they prefer to be like that? Because they combine here and they form the inner gas electron configuration. We did that already. Okay, these go have the duplex here. And the other ones will share a pair of electrons there to form the octet because they gain stability. Same thing is showing you here how you find the molar mass for oxygen. Okay, so you have 2 moles of oxygen atoms forming 1 mole of molecules. See? 2 moles of oxygen atoms combined together to form 1 mole of molecules. And they say the molar mass for that is 16. When you combine these together, 2 of them, you end up with 32 grams per mole, which is the same thing that we have here. Okay? Finding molar mass for hydrated salts. Some salts, like these that are shown here, when the crystals are formed, they incorporate into them something called water of crystallization. Every mole of calcium chloride will have 2 moles of water along with it. This one here, 7 moles, magnesium sulfate, sodium sulfate 10, sodium thiosulfate 5, and trioxide 3. If you have to find the molar mass for magnesium sulfate now, you don't only have to do it for magnesium sulfate here. You have to add to that the mass for 7 moles of water, because these are always connected to these when they're there, okay? Unless they tell you this is called hydrated magnesium sulfate, but if they say anhydrous magnesium sulfate, then water will not be there. The water has been pushed out from it. So in normal circumstances, they show you the formula here. You have to find the molar mass for this, and then add 7 moles of water to that, and everybody should know how to do that, right? So we're showing you here how you have this guy here, 1 mole of that guy there, with 7 moles of water. So find the molar mass of this one first. You should know how to do that. You have how many magnesium? 1 magnesium. How many sulfur? 1 sulfur and 4 oxygen. And that's how you do that. That is for 1 magnesium. This will be for 1 sulfur. And of course, this here for 4 oxygen. When you add it all up, you get that number, grams per mole for magnesium sulfate. Now you do, what is it for 7 moles of water? Before you do that, you have to find a molar mass for 1 mole of water. And you end up with this. But this is just for 1 mole, right? What do you have to do? You have to multiply this by 7. And the answer you get, you'll add it to this guy here. And that will what will be for magnesium sulfate heptahydrate. This is what you call them, eh? Let me just do that for you quickly. This will be calcium chloride dihydrate. This will be sodium sulfate decahydrate. This will be heptahydrate. This is pentahydrate, and this will be trihydrate here, okay? You call it depending on the number of moles of water molecules that are connected to those there. So that's how we do now. Multiply this here by 7, and you ended up over 7 moles of water, okay? And then now the full thing is going to be molar mass of this will be equal to 1 mole of this, 7 moles of water, and these are the values you just calculated. Add them together, and that will be the molar mass for magnesium sulfate heptahydrate. Okay, so quickly, when you see that, find the molar mass for the compound here, and then you find the molar mass for the number of moles of water that you have there. In this case, it's 7, and you add these values together, and that gives you it. If they ask you now to find the mass for 0.5 moles of this guy here, how do you do that? You can do it 2 ways, by finding the molar mass for this and multiplying this by 0.5. So you find the molar mass and you multiply by 0.5, and you'll get this value. And these are some questions for you to practice. The solutions for these are in the solution manual. These problems have been restated in the solution manual. Okay, so you can, my advice to you is to at least buy the solution manual if you can't afford to buy the book, and check out and do them, and then compare your answers with what is in the solution manual. So I hope that was useful. See you again in the next video.